So 3 system of equation word problems. You may solve them using substitution, elimination, or graphing. I don't care. The key is to be able to set up the system. If you can set up the system right, then you're good to go, okay? So here's the steps that I want you to take. So everybody, we're going to do the odds together, or at least some of the odds together, and then it's going to be your job to work on the rest in class. Let's take a look at problem number 1. The first thing we want to do, step 1, is we want to define the variables. So in this problem, it says find the value of 2 numbers. So we're going to call x the first number and y the second number. If you use a and b, if I use x and y, if somebody else uses n and m, doesn't matter. Just define your variables and say what they mean. The second thing you want to do is you want to find your 2 equations. Usually they're going to give you 2 different pieces of information. If it was a real life application, I bought 20 of these things and their total was. So sometimes they might tell you about how many you have, and then also it might tell you how they're related. It might tell you what they cost, things like that. So the 2 equations, it says their sum is 12. So x plus y equals 12. Sum means to add. And their difference is 4. Once you find the 2 equations, then you're going to solve them. When you solve them, feel free to use elimination, substitution, graphing, don't care. You pick a way and do it, okay? And then the fourth thing we're going to do is we're going to explain our answer. So every single time, you should do those 4 steps. Define your variables, find 2 equations, solve those 2 equations, and then explain our answer. We've done 1 and 2. We have defined our variables, and we have the equations now. So now let's go ahead. After we've done that, let's go ahead and actually solve it. What's really great about this is that our y's are already opposites. If our y's are opposites, all we got to do is add the 2 equations together. So all you're going to do is put a little plus sign. This is a good one to use elimination on because that x is different. They're opposites. Because your x, your y, your equal to, and your number are all lined up perfectly, it's a really good example of using that elimination method. When we go and add the 2 together, we get 2x equals 16. And then at this time, we just have to divide off that front coefficient. So our x is equal to 8. Now, we haven't solved it completely. Remember last time you had a little bit more work to do. I'm going to stick that answer in up here. You can stick it into either equation. Doesn't matter which. I know that 8 plus y is equal to 12. Just take out the x in one of your equations and replace it with the value of 8 that it is. If I subtract 8 from both sides, I get y is equal to 4. So I've solved it, but I should explain my answer. And so my first number is 8. My second number is 4. And then just ask yourself, does it make sense and answer the question that they gave me? Are the 2 values sum 12? Yeah, 8 plus 4 is 12. Is their difference 4? Yeah, 8 minus 4 is definitely 4. So it's very important in math word problems that this last 5, you ask yourself, does it make sense? Because it has a real life context, or in this case, just some words that go with it, it doesn't make sense, okay? So define your variables, find 2 equations, solve them, explain your answer. Does what you got make sense in the context of the problem, okay? So that's an easy one. So then I'm going to let you do 2 But we're just going to keep going and do kind of some of the odds together. Do we have any questions about their first problem?
No.
Are we good? Okay. Okay, so we're going to skip 2. That's on you. Let's do number 3. Okay? Okay, so it says, flying to Kampala, wherever that is, with a tailwind, a plane averaged 158 kilometers per hour. On the return trip, the plane only averaged 112 kilometers per hour while flying back into the same wind. Find the speed of the wind and the speed of the plane in still air. Okay. Now, let's think about for a minute what our variables are going to be. I will call the speed of the plane P. I'm going to call W the speed of the wind. Okay. So I've defined my variables. If you want to call them X and Y, go for it. It doesn't matter. I just use P and W to help me keep track of what is what. Okay. So the speed of the plane, I'm going to call P. The speed of the wind, I'm going to call W. Now let's find our 2 equations. I know that the plane plus the wind, so when the wind is pushing the plane and they're working together, they went faster. They went 158 kilometers per hour. But on the return trip, the wind is pushing against the plane. The plane is fighting the wind. So the plane minus the wind is 112. So now let's think about what we've done. We've defined our variables. We used this piece of information for our first one, and then we've used this piece of information for our second one, okay? So now we've got our equations. So now we pretend like the word problem isn't even there, and we just go ahead and we solve it using any of the techniques that we've used before. Again, this is a great elimination because the W in one is positive. They're opposites already because it's in the negative in the other one. So we get 2P equals 270. So the P is 135. Now let's put some units on it. So for the last problem, we didn't have units. And so remember, when you explain your answer, please use the units that are given. And so that's kilometers per hour. Now, are we done? Did we answer the question? Find the speed of the wind and the speed of the plane in still air. Did we answer the question? No, we're not done. Have we done that? No, we don't know the wind yet. But if we stick it up here into the problem, the plane plus the wind is 158. And then if we just subtract 135 from both sides, that would be 23. And what kind of units would we use there? Speed of the wind. Same thing, that kilometers per hour. And then let's take and put our answer in words. Okay, we want to explain our answer and use the units. Okay, so the plane went 135 kilometers per hour. The wind went or was 23 kilometers per hour. Okay, and then you can check when they were working together, it should add up to 158. When they were fighting against each other, the difference of them is 112. So it works, okay? But you should be consistently doing that. And then always go back up and say, did I answer the question they asked me? Find the speed of the wind. Check, 23. Find the speed of the plane. Check, 135. So please make sure that you are answering the question. And so that's why that doesn't work. You kind of do in your head. You don't really have to write anything for that step. That is just, did it make sense? Does that kind of make sense? Okay? Okay. Everybody got number 3 down. I want to do 4 because I want to do one that talks about money. Money. Yeah, let's do 4. Okay. I kind of want to do like one of each so then you have the opportunity to do the others for yourself. Let's look at 4. It says the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of 38. The school took in $52 the second day by selling 3 senior tickets and 2 child tickets. Find the price of a senior ticket and the price of a child ticket. So the first thing we're going to do is define our variables. So we'll call S our senior citizen ticket. And we'll call C our child ticket. And then we need our equations. And so let's pull out this first sentence for our first equation. It says on the first day of ticket sales, the school sold 3 seniors. And that would be the senior ticket price. Let's specify that would be the price. They sold 3 senior tickets and 1 child ticket for a total of 38. Okay. So our equation is going to go 3 of the S's plus 1 of the C has to total 38. So that's our first equation from that first sentence. Okay. Now our second sentence here, let's read that one. In that day, they took in $52 by selling 3 senior tickets and 2 child tickets for $52. And then my sentence says, find the price of the senior ticket and the price of the child ticket. Okay. So we have that system. Can we do it like we did it before without any changes to our equations? No, we have a little math to do. This one, since there's one of these, you could bring this over here and do substitution. That would work. But I also noticed that we've got these 3 S's that match in both. So to make them opposites, let's multiply this one through by -1. Okay? When I do that, the top equation I've decided not to do anything with. The bottom equation, if I multiply everything through by -1, that's what I get. Okay? Now, because that 38 was smaller, if you decided to multiply everything on the top equation through, that's fine, however it works for you. We get -1C is equal to -14. And so C is 14, and it would be dollars. Okay. Now, once we know what the child ticket is, remember we're not done because we haven't answered the question fully. We have to find the senior ticket and the child ticket price. So let's take this 14, and I'm going to put it in this top one. It doesn't matter. But so I know 3S plus 114, which is 14, is 38. So 3S, 38 from 14 is 24. And so a senior ticket is $8. Let's put our little dollar symbol. Now remember our steps again. We defined our variables. We found the 2 equations. Then we solved them. Then we need to explain our answer in words. So the senior ticket price is $8. And a child ticket is 14. Sorry, I ran out of room to write the word ticket. Let's put ticket right here. Okay. So it kind of, you just have to try to interpret that a step at a time, a sentence at a time. Anybody have any questions about number 4? That makes sense so far? We good? Okay, so let me try to find. So 6 is like that top one. 8 is like, well, that's a little different. There's some ticket sales. There's a lot of downstream and upstream ones. Let's do 8 together, and then you'll have the rest of class to work on your own. Okay. So our first step in number 8, after we read the questions, is to write a variable. It says the senior classes at high school A and high school B plan separate trips to New York City. The senior class at high school A rented and filled 1 van and 6 buses with 372 students. High school B rented and filled 4 vans and 12 buses with 780 students. Each van and each bus carried the same number of students. How many students can a van carry? How many students can a bus carry? So these sentences kind of give us what our variables are going to be. Let's call V to be the number of kids that can be in a van. And let's call B the number of students in a bus. My beautiful writing. Okay, so we're just defining what those are. That's our first step. And now we're going to set up the equation. Now first, let's use the information we found about high school A. They did 1 van and 6 buses for 372 students. So 1 van and 6 buses hold 372 students. So 1V plus 6B is 372. Okay, now that we have that, then we've got to use the second sentence. So you should be using most of the information they've given you. So this time I know 4 vans plus 12 buses is 780. Okay, so that is our equations that we have to solve. Now, I decided that I think putting the B's together will be good. So I need to multiply through by -2 to make that not only a 12B, but I need it to make it a -12. Okay, so let's go ahead and multiply that through. So we get -2V, -12B, and 744, I believe. Yeah, okay. Oh, and it would be negative. I'm sorry about that. Okay, and then the last equation, we're not changing. 4V plus 12B equals 780. And now we're just going to add those 2 equations together. Now, the reason we can do that is because these are opposites. They are going to cancel out. And that's why I like elimination a lot. You don't have to use elimination, but you definitely can for this. So we get that 2V equals 36. So V equals 18. So are we done? No, we're not. So find an equation that has a B in it. The top one has a B in it. 6 times 18. 6 times 18. So if I want that 6 times that number I just found, that's 6 times 18, I threw in a calculator, there's 108. So 1V plus 108 equals 372. Oh no, I put it in the wrong spot. I'm so sorry. It's a V, Mrs. Hott. The V's are over there. So that's 18. Plus 6B equals 372. So let me say that again. I found V, so put it in the V spot, which is there, 18. 18 from 372 is 354. Just got to divide by 6, and that will say how many are in a bus. So there are 59 possible people in the bus. Okay. So we're not done until we write down what answers the question. How many students can a van carry? A van carries 18 people or students. And then a bus carries 59. Okay. So does that make sense? Well, sure, the van should be less than the bus. That's right. If we did 18 for the van and 6 buses of 59, you should get 372. So you should be able to put them back in and it makes sense to you. But always make sure you're summarizing what you got and then asking yourself, does it make sense? Are we good with these? Now, the answers are on the bottom. But if you just write down the answer, I don't care. I want to see that you can set them up. So use those answers as a guide to check your work. Oh, I didn't get that. Why didn't I get that, Mrs. Hart? Show me. And I'll be more than happy to help you, okay? So the rest of the class, please be working on setting these up, using the 5-step process as you go through each of these problems. Do we have any questions for the good of the order?
No.
Okay.
Ian from the